Hello everyone, in today's video I will be talking about the alphaRS software setup and features. The first thing you want to do is double click on the alphaRS icon and open up the software. You want to make sure that the alphaRS system is on, the head stage is connected, and the Ethernet cable is also connected. Once you open up the software, the first thing you will see is a pop-up window which indicates an empty workspace. For now, we will click OK and go back to this later. Click on the shortcut key Ctrl-Shift-A to open up the system state, and we want to update the core MAC address. The core MAC address of the alphaRS system is found on the bottom side. We want to change it and click OK. Once you click OK, you will be prompted to restart the system. Make sure you keep the system on during this process and the software will reopen automatically. There's no need to reopen it after this. Click OK, and then you want to click Yes again, and just wait. Once the software reopens, we can click OK again, and then we see the system is booting up. In the status bar over here, we see that the main unit has been recognized and the head stage has been also recognized. The following status bar shows an indication of the main unit connectivity as well as the head stage ports. There's 8 of them, and the one that's green is the head stage that's connected in the alphaRS system. The other 2 icons is for connecting to the SDK. After confirming that the system is running from the status bar, everything is connected, we would click on the head stage setup. In the head stage setup, we basically look at the port where we have the head stage connected. We want to make sure that the correct head stage has been recognized by the system. In our case, it has been recognized. Otherwise, we would need to select the correct head stage. And once we do so, we would click Reboot, see the menu, the ribbon, and the toolbar. The other section, it's the workspace area where we see the channel display. And then the bottom section is the status bar. You can customize your own workspace by building new groups of selected signals, or you can use the default workspace found in the default workspace folder. For building your own workspace, follow the instructions found in the manual. For demonstration purposes, we will use the default workspaces. To open up the default workspaces, we will go to File, Open. You want to navigate to Program Files, Alpha Omega, alphaRS, Default Workspace folder. And over here, you will see all the default workspaces. If you bought a basic package, there will be 4 default workspaces available for you to use. If you bought the advanced package, you will see 8 default workspaces for you to use. For this tutorial, I will use the default workspace 32 channel B. Once you select the default workspace, the software will automatically restart. We see the head stage reconfiguration pop-up window appear. We can say reconfigure, and we want to double check that the correct head stage has been recognized. Over here we have a suggestion for 32 recording. We would click so, press reboot, and make sure that a verified connection appears, and then click OK. You might need to double check on the system state that the core MAC address is correct if the connection does not work. Otherwise, you're good to go. I would recommend for you to make a copy of the chosen workspace before changing anything. So to do so, we would go back to File, Open, and in the default workspace. To make a copy, you would simply click on the workspace, right-click, press Copy, and then in the same area, you can paste it. You can also rename the workspace differently. For example, over here, we can name it Tab 1, and you can do as many copies as you want. The purpose of the workspace is to save the chosen settings by the user and the different signal display windows, which I will touch upon shortly. We'll start by introducing the main features of the 32-channel default workspace which we chose. All the windows mentioned earlier are flexible and can be closed and reopened. They can be enlarged, minimized, and so on. You can also reorganize and place the windows anywhere in the display area. For example, I can close the 16 input port window. I can close the TTL window, enlarge the LFP, and if I want to restore the default layout, I would simply click on Restore Layout. And now I see that the digital input port and 16-bit and TTL have reopened. Now let's say we want to change the default layout of the workspace. So for example, I can close the digital input port window, the TTL window, and the LFP. I can reorganize the SPK to the left side and enlarge the main segmentation and main window. And to save the following layout, I would need to press on the shortcut key Ctrl-Shift-S. And on the menu bar, we see that an admin appears. So we can click on admin and click on save as default layout. So right now, if I click on the icon in the toolbar, which says restore layout, I would have this as my default layout. So as an example, I can close the SPK window. And if I was to click again on the restore layout, the SPK window reopens. Now other display groups are available and they can be reopened from the window tab in the menu bar. For example, we can reopen the LFP window again. We can reopen the digital input again, and any other window that we desire. Now any window that's open in the display area would have a check mark next to it. So for example, here we have the following, and if I was to close, let's say the LFP, it's indicating that it's closed. Now moving away from the display area, the top side of the software is where we have all the setup options. For example, looking at the View tab, this is where we can control what appears in the ribbon. For example, if I was to click on Audio, I see that the audio setup appears, and if I was to remove, let's say, script, the script options disappear. So the view option allows you to customize which buttons to appear or hide in the ribbon area. Now there are 3 fixed buttons in the ribbon area and they cannot be removed. These are the hit stage setup, which I mentioned previously, the save button, which is responsible for starting or stopping the login data, and the imp, which is the impedance check. Now I will be explaining more about the windows in detail. Looking at the SPK window and the main segmentation window, each box or adapter has a channel. For example, the following box has SPK1, which is channel 1, and so on. We have channel 2, channel 3. If we look at one box over here, we see that on the left top corner, we see the channel ID. For example, here it's SPK1 and it's shown in green. We see the threshold line value, which is the threshold line that we can select anywhere, and it's shown in blue. And then we have the y-axis line value shown in pink. In each box, you will see a sound icon, which can be activated or deactivated by pressing on the following icon. For example, currently sound is deactivated. If we want to activate it, we would simply press, and we see now that the sound has been activated. Now, if you want to zoom in any specific channel, for example, in box 1 for channel 1, I would hover over the y-axis, I would left click and hold, and then I can drag it up and down to zoom in or out in the channel. The same thing goes for the x-axis. We can left click and hold, and then drag it right and left to zoom in or out. In some groups where time is constant, the x-axis cannot be changed. Now, as mentioned previously, the threshold line and the main segmentation window are connected. For example, if I click on channel 1, we see channel 1 in the main segmentation. And if you look at the blue line, if I was to change the blue line from the window, the main segmentation window will also change. And the same manner from the main segmentation, if I was to change the threshold line from here, it would change also in the spike channel window. So I've shortly switched to the 32 channel advanced workspace in order to show its features. For demonstration purposes, we use a simulator to inject brain data. As a start, over here we have in the display area the SPK channel window that shows us SPK channels from 1 to 32. These are the high frequency signals. So over here we have the segmented display for spike groups 1 to 32. This shows us the SPK signals that passes the threshold line is the following blue line found in the adapter box. In the following segmented display window, we used spike sorting by using template matching method. Over here, we used 4 different templates to sort 4 different units as shown in 4 different colors. Now, this is the main segmentation window. It's for spike sorting for the segmented spikes. You can click on any channel from the segmented spikes and do the spike sorting on the main segmentation window. The segmented spikes and the main segmentation windows are connected. For example, if I was to double click on the segmented channel 1, I would see channel 1 in the main segmentation, and I can change the threshold line from the segmented spikes, and the threshold line will change accordingly in the main segmentation window as well. Let's do another example. We have channel 9. You see now channel 9 in the main segmentation. And also changing the threshold line from the main segmentation window will change it in the segmented spikes window. Now for more information about the spike sorting, check the user manual. And over here we have the main display window which groups different signals. So it's the same signal filtered as low pass for LFP, high pass for SPK, and unfiltered for raw. And all these signals are from the same contact. Now, in the same manner as in the main segmentation window, the main window is also connected to the segmented spikes. So if I was to click on another channel, the same channel I clicked on, in this case 13, will appear in the main. And over here, as we see, it shows 13. Lastly, we have the bottom window for digital inputs. For example, over here we have the 16-bit port. We can also see another digital input for the 4 TTL inputs that we have. Now moving back to the 32 channel basic workspace. Now looking at the simulation setup, if it doesn't appear in the ribbon area, we can just simply click view and click on current simulation and make sure that the check mark appears. Now looking at the simulation setup over here, I have connected an extra head stage that contains simulation in order to activate it. Looking at the stim contact, this is where we can choose in which channel we want to perform simulation. It can be any channel of the following. Now stimulus is where we can change the amplitude of the stimulation pulse. We can increase it or decrease it accordingly, and the step size, the default one, is 0.1 milliamps. In order to change the default step size, we can click on stim setup and change it. For advanced stim setting, if we press on the stim setup over here, we can change the pulse shape, for example, from biphasic to anything else. We can change the frequency of the pulse. We can also change the amplitude, the default step size, and so on. Or the stimulus amplitude can be inputted by the user using a script. Now, once all the stimulation settings are set, you can press on the stim button to start stimulation. You can press and hold on the stim button for a continuous stim train. And in the setup, the state can be changed as a trigger for turning on and off the stimulation. Now, any channel can perform stimulation or recording by choosing the specific channel from the stim contact. You change the channel from recording to stimulation. For automated stimulation, a script can be configured to perform a customized stimulation setup and form. And this is by showing the script and uploading the settings over here. Now, script can also be used to control system features as digital input, digital output, and stimulation, and can also be used to trigger the stimulation and digital output from specific data. Now, moving on, I will be explaining some features from the Options tab. Let's start with the login options. There are two login mode options, manual and external trigger. Manual save is the save button which we saw outside over here, and the external trigger setting is found over here. We can set any TTL to be an external trigger, and we can also configure it to be positive edge or negative edge. Once we choose the TTL as our external trigger, we basically have it as an input switch file trigger where we open a new folder for each trigger. Now looking at the login file setting, over here we can change the path of where we have the file saved. We can also change the name of the login file, or we can choose the automatic name. And then we have the file size limits. Over here we can limit the file size by maximum file size or by the duration, which is the maximum file time. Now the last thing about login options, if we look at the bottom side and see select channels, this is where we can basically customize which channels we want to save data from. If you want to save data from all channels, simply click select all, and then you are saving and logging data from all the channels. Otherwise, you would have to manually select which channels you want to log data from, and then click OK. Once done, we click OK. Now going again to the Options tab and opening the impedance settings. This is where we can choose all the impedance settings. There are two parameters that can be altered. These are the voltage and the frequency. The setting is a sine wave output with a specific voltage and frequency. Then it measures the voltage on the electrode, and that's how the impedance is calculated. In terms of frequency, we have options from 30 Hz up to 1000 Hz. And in terms of voltage, there are two options, 0.3 and 0.03 volts. We usually use bigger voltage for macro contact and lower voltage for micro contact. Now, in terms of the input cable parameter, we can leave this unchanged. Since a digitized hit stage like the alphaRS hit stage, we can neglect the input cable length. Once done, we click OK. Going again to the Options tab, we click on Channel Settings. Now the Channel Settings window shows us a table that gives us the status of each channel. For example, over here we have the name of the channel ID, the software high pass and low pass filters, the gain of the channel, state if it's on or off, the sampling rate, the type if it's LFP, SPK, and so on, and the software reference as well. Through channel settings, for example, if we press on the first one and we can say change name, we can change the name of the channel. Also, the filter settings can be changed in filter properties. Now in filter properties, we can change the filter settings per contact. We can turn on or off the filter per contact. For example, if we were to go to contacts, we can have a group of channels that have the same filter settings. For example, over here, if I was to press 20 to 22, this gives me that channels 20 to 22 have the same settings for the software. I can also jump channels, so I can do 20 to 22, and also I can press comma, and then have channels 25 to 50, for example. And in this manner, they all will have the same filter settings. And if I know that I have, for example, only 32 channels, I can simply have 1 through 32, which covers all the channels, have the same filter settings. Otherwise, I can have one contact that has the following filter settings. Now, as seen, the software filter settings are flexible. For example, the LFP, the low pass, and SPK high pass settings can be changed, and multiple settings can be inputted for different contacts. Once done, you would press OK and have the settings changed. Now the last feature I will mention is the AutoSet level. We can access the AutoSet level feature by going to the Tools tab and pressing AutoSet level. The AutoSet level is a very useful feature for automatically adjusting the threshold line, which is the blue line I mentioned earlier. Before, we can drag the threshold line up and down to set the threshold level, but using the AutoSet level, we can automatically define the following line according to the RMS background noise level. So to apply this feature, the first thing you want to do is choose which channels you want to apply the AutoSet level threshold line to. For the purpose of this example, I will choose all the channels. So I would check the upper box that checks all the channels. And then I would need to choose the polarity of the calculation. And in this case, I'm choosing the negative falling, positive rising. And once I've done all these selections, I would click on Calculate Level. After calculating, we see that the RMS has been calculated for all the channels that I've checked. And the last thing I need to do is click Apply, and then OK. And once I do so, I see that all the threshold lines have been adjusted according to the AutoSet level calculation. Now this feature sets the level line below or above the background noise, so the user can get the multi-unit and single unit in the segmented window, which was shown previously in the advanced 32-channel workspace. Thank you.